So in Bash, it's possible to choose to do different things based on what the user inputs. For example, we might not want to run this command at all unless the user actually gives an input file, $1, and an output file, $2. Because there's no way for us to do anything useful without those files. So what we do instead is to give the user an error message that they tried to use the script incorrectly and then just abort the execution of the script. Now the first thing I'm going to do is to change the documentation to reflect the fact that we're no longer actually reading from the standard input and writing to the standard output. So read a text file $1 and compute a frequency list of the words in the text. And print output to the file $2. And print output to the file $2. So this variable $hash tells you how many command line parameters were passed to the script. Now we'd of course like this to be equal to 2 because we need an input and an output file. So to check that the value is 2, we're going to use the if statement. So what we'll actually do is to check if the number is of command line arguments is not 2. And if it's not 2, we want to print an error message and exit the program. Otherwise, we're just going to go to processing the input file and printing to the output file. So we're going to write if here, and then an opening bracket to indicate that this is a condition. And then this $hash sign, and then not equal to, which is signified by NE, not equal to 2, and then a closing bracket. So basically, if the number of command line arguments is not equal to 2, then we're going to do something. And what we're going to do is to print an error message. Echo error. Wrong number of command line arguments. And then a message about how to use the script. Usage reclist.sh input file, output file. And then after printing these messages, we're going to exit the program. So exit 1. The number 1 here is an exit code. The normal exit code is 0, and when something goes wrong, you usually give an exit code 1. There are other more specialized error exit codes as well, but these are the basic ones. Okay, then we need to close this if off. And to do that, we write fi for final, I guess. Now it's customary to indent the commands inside the if block so that this becomes a little bit easier to read. So let's test this thing now. So I'm first going to call reclist.sh without any arguments. Oh, I had a typo there. I need to fix that. So in any case, we get the correct output. And we can see that the error exit code was actually the code 1 marking an error. And we can do that because the exit code is stored in this $? Variable. So the exit code of the last process that terminated is always stored in this $? Variable. So let's call it the right way. So now I'm going to give an input file and an output file. And after this, the exit code is 0, which marks a successful application of this command. Great. So there are a few conventions that people usually do when writing these scripts. Let's go back to Nano. And one of them is that you usually don't mention the name of this script. Because if someone happens to rename your script, it may become confusing. So that's why you usually substitute this concrete program name with a variable $0. So the $0 variable in this bash script will always contain the name of your program or your script that you're running. So let's try this. So I'm gonna save and exit again. And then let's run freglist without any arguments. And it still prints the name of this program now. Let's look at a slightly more complicated script next. This will be a script for printing concordance lists, like this conc.txt. In this list, we have occurrences of the word queen in some data set or file and some amount of left and right context. And usually you format them so that all of these occurrences of the center word queen are aligned. And it's easy to get an overview of what's the left and right context. So let's quit using Q. We're going to need a Unix command called printf for this. And printf comes from formatting print. As the name says, it will print its arguments formatted in a special way, which we can specify. Now, this is probably one of the most versatile commands we have seen in addition to sed. So we're just going to look at a little bit of what it can do. The typical use is actually to print numbers rounded to a desired precision. So for example, printf, and then a specification for how we're going to format. So %2f. And then we're going to give a floating point or decimal number as input. So 1.2291, for example. And this is now going to round this number to 2 decimal places, which you can see here at the beginning of the line. Now, printf only prints exactly what you ask it to print. If you don't ask for a new line, it will not print one. So if we print one at the end of this formatting specification, we're going to get a nice line with 1.23. So why we want to use printf is because it can help us print. So why we want to use printf is because it can help us align all of these occurrences of the center word queen, for example. And the way it can do that is because it allows you to specify a minimum width for the output. So for example, if we add 20 in front of the dot here, we'll get the number printed in width 20 and the padded with spaces if needed. So let's count this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20 characters. So printf printed this number formatted to precision 2 decimals in an exactly 20 character wide field. Great. Now let's think about this concordance in script. So let's open something nano conc.sh, conc for concordance. Now again, we start with the hashbang. So hash, exclamation mark, bin, and bash. And we're going to take 3 arguments. The first one is a center word form, like queen, The second one is an input file. And the last one is an output file. And let's write some documentation too. So script conc.sh and author which is me, of course. So this is a program which reads the input text file i5 finds all the occurrences of the center word WF and prints a concordance list of those into $O file. So what we want to do is to find the lines which mention our word form, and to do that we of course will use grep. So start by opening the input file and pipe that to grep-e for extended regular expression syntax, and then we're going to find occurrences of the word form queen. So if you remember, \b marks boundary. So either line end or start, or a punctuation of white space character. And actually, let's start by piping that into the O file and just looking at what that looks like. So I'm going to save and quit. And I'm going to make this an executable. So give the user permission, execute permissions for this file. And then let's call it so conc.sh. We're going to search for the word queen. And then we have our input file, which is life of b. Let's use the sentence file actually. So this is going to be the file with the sentence per line format. So life of b.sent, which was created last week. And then we're going to have our output file, which is life of db.conc. And let's look at the output. Now we see that we really do get all these lines with the word queen on them, but these queen words are not aligned, so they're just really all over the place basically. So let's quit less and go back to Nano. So we need to specify a number of characters of context on the left and right side of the center word. And if the number of context characters is the same on all lines, then the queen words will be aligned in the output file. So I'm going to say that I want a context of size 30 characters. And I'm going to clip everything beyond that. So to do that, I'm going to use sed. So sed-e, again for this extended regular expression syntax. So we have everything from the beginning of the line. And then I'm going to capture the 30 characters here. So and then the following word form, which is now supposed to be queen for us. So we're going to capture 30 characters before the center word form, and the rest of it, the preceding context before this thing, is going to be just thrown away. So the only thing we're going to retain is 30 characters until the center word form and then the center word form. And then I can do the same thing on the other side. So here we begin with the center word form. And then I'm going to retain 30 characters after the center word form. And then until the end of the line. And again, I'm going to throw away everything after the 31st characters preceding the center word form here. Okay, and then I actually need to remove this redirecting to the output file and move it over here. And then I'm just going to quit Nano and save and use less to check how it turns out. So rerun this command and then less. Now if I search for queen again, I can see that most of these queen words are actually now aligned. However, some of them really are not aligned yet. And the problem is that some of these lines actually did not have 30 characters of preceding context and succeeding context before and after the queen word. So to help with that, we need to pad on the left and right side. So let's quit less using Q and then nano conc.sh. Now I'm going to form some padding for me that I can append to the left and right side of the line before we clip away stuff. And this will guarantee that every line will be at least 30 characters before the queen word and 30 characters after the queen word. So to form a padding of 30 characters, I'm going to use the printf command. So printf, and then what we're formatting. So the way to specify the formatting here is to use this context variable and then an s. So this means we are formatting a string and we want to print it to a field which is at least 30 characters wide. Now, unfortunately, the command line interpreter will think that s is part of a variable name, so it will think this is actually context. So to avoid that, we need to protect our variable name using these curly brackets. And then what are we going to format? Well, just the empty string, basically. So what this thing does, it is going to create us a string of 30 space characters. And now we actually need to use this in a sed command. So what we do is we capture it into a variable, and there is a syntax for doing this in bash, and it looks like this. So pad, that's the variable name, equals, and then we use this backtick characters. And then now, before I clip anything, I'm going to pad my string on the left and right side so that it'll be at least 30 characters before and after the queen word. So yeah, let's use sed to do this. So we're going to match the entire contents of the line, and on the left side we're going to add some padding. Then we have the match here. So everything that was matched by this expression is going to be in the ampersand variable here. And then we're going to add padding on the right side. So I actually had a syntax error here. This curly bracket is supposed to be on that side of the dollar sign. So let's run this again. And now if we check what happened using less, we can see that all of the queens are now aligned. So this is one way to create a very simple concordancing tool using Unix commands. Now there is one caveat here. If you have several occurrences of the queen in the same line, this will only print the first. So if you really want an advanced concordance tool, you need to do something a bit more clever, but this is already quite useful.